Click the bell icon to get latest videos from Ekeeda.
Hello friends, I welcome you all to this video. We are with chapter 6 of microwave engineering, where a family of microwave bipolar junction transistors we started with. First of all, understanding the amplification phenomena. Before that, we have also seen various configurations, the power frequency limitations, the operating principles we are covered with, and solved certain problems also. Then we followed with the family members as like the heterojunction BJT, the JFETs, metal semiconductor field effect transistors. Then we had the high electron mobility transistors, and now the metal oxide semiconductor field effect transistor. So based on to the recent learnings of the last device, let us have one problem. So here we have a problem statement. A certain p-channel MOSFET is the abbreviation for metal oxide semiconductor field effect transistors. A certain p-channel MOSFET has the following parameters. Na is equal to 3 into 10 raised to the power 17 per centimeter cube. Epsilon r is equal to 11.8. Epsilon suffix ir is equal to 4. D is equal to 0.01 micrometers. Capital T is equal to 300 degree Kelvin. In the parts A, B, C, we require to make computations. For part A, calculate the surface potential denoted psi suffix s in the bracket I and V for the strong inversion. In the part B, we need the insulator capacitance, and lastly, the determination of threshold voltage is expected in this problem. So we begin with first of all identification of the given details. So in the problem statement, we are first of all provided with a value that is a kind of concentration. So the given detail, it is nothing but the doping concentration. So doping concentration is having the value 3 into 10 raised to the power 17 per centimeter cube here. The next value is of the dielectric constant, that is of relative type. So ES is equal to 11.8 is provided to us. It is having the next parameter represented as epsilon suffix IR is equal to 4. This is again the relative dielectric constant, but this is for SiO2, the silicon dioxide. That is why the device name MOSFET we derive. After this parameter, we have a measurement denoted by D in terms of length, so that it is 0.01 micrometers. As we have insulator into the use, this is the insulator depth. And the last parameter is provided to us, that it is T. So T is the operating temperature, that it is 300 degree Kelvins here. Getting back to the problem statement, now we need to solve for part A. The surface potential denoted for the strong inversion is to be calculated. Now the surface potential is given by the formula. The surface potential is represented psi suffix s. In the suffix only I mention I and P. So this is equal to twice of capital Vt natural logarithm for the ratio of Na to that of Ni. So we have the values 2 as it is. Vt value is a constant, that it is 26 into 10 raised to the power minus 3. We take the natural logarithm, and in the numerator we put the value 3 into 10 raised to the power 17, whereas the denominator is substituted by 1.5 into 10 raised to the power 10 for the assumption that it is for the silicon. Now we make the computations to obtain this value, and the computation results into the value 0.84874 here. So this is in terms of volts here. So this is the required value psi suffix s for I and B is computed and outlined here. So here we are finished with calculation of the surface potential for the strong inversion. Now we require the value of computation of the insulator capacitance. Before going for insulator capacitance, whatever the answer we have obtained for part A, that we have represented as psi suffix s, I and V, this is actually having a relation with psi suffix B by 2 like this here. Now in the part B, we focus our attention for the calculation of the capacitance. The insulator capacitance can be denoted as C suffix I, and it will be a simply ratio of epsilon suffix I divided by the dimension of D here. So making the substitutions, here we use the dielectric constant into the 8.854 into 10 raised to the power minus 12, and the dimensional value in the denominator is 0.01 into 10 raised to the power minus 6. So this results into 3.54 into 10 raised to the power minus 3 here. As this is with respect to the measurement of dimensions here, it should be measured in terms of farad per meter square. Finally, we represent insulator capacitance C suffix I is equal to 3.54 millifarad per meter square. We outline the value here. So now after determination of the insulator capacitance, we require the threshold voltage. So for determination of the threshold voltage, we have the formula to be used in part C. Threshold voltage VTH is computed as twice psi suffix B added with twice by C suffix I in multiplication to the square root of epsilon suffix s into Q into NA into psi suffix B. Hence I put 1 by 2 as a power to this bracket here. So now psi suffix B can be obtained from the relation I have shared before the part B here after the answer of part A. So here we make the twice of psi suffix B is equal to the answer from part A, that is 0.874. This is added with, we have 2 divided by 3.54 into 10 raised to the power minus 3 in place of C suffix I. In the bracket, we hold 8.854 into 10 raised to the power minus 12 into 11.8 for epsilon suffix s. In multiplication to, here we have Q as 1.6 into 10 raised to the power minus 19 into the concentration, that value is of 3 into 10 raised to the power 23 in multiplication to psi suffix B, the half of the answer from part A, that is 0.437. So this has the power 1 by 2 here. The simplified step gives us 0.874 added with 0.56 into 10 raised to the power 3 into 14.80 into 10 raised to the power minus 4. Finally, the value is 1.70 in terms of volts here. So this is the value of required threshold voltage I have outlined. So this way we are covered with the answers for part A, B and C for the given MOSFET. In the next lecture, we shall be having a practice of second problem onto the metal oxide semiconductor field effect transistor. I hope you are enjoying the details and the practice of problem for this subject. For more details and the knowledge, you can subscribe to Ekeeda channel. Thank you.